Hello Tangam, welcome to GullyClassroom. This is the 5th lecture. In which chapter, sir? In the chapter Light, Reflection and Refraction. In CBSE 10th Standard Physics, chapter 10, Science Book chapter 10, Light, Reflection and Refraction. This is the 5th lecture taken in English. This is the 5th lecture taken in English. Okay, sir. What are we going to learn in this 5th lecture? In this 5th lecture, we are going to work 4 different models of problems which are based on spherical mirrors. 4 different models of problems which are based on spherical mirrors, which have been repeatedly asked in old CBSE Board question papers. Before you work this particular problem, you need to know the content of the previous lecture. Especially you need to know the spherical mirror sign conventions from the 4th lecture, and you also need to know the 8 different diagrams which I have drawn in the 3rd lecture. Sir, what are those 8 different diagrams that you have drawn in the 3rd lecture? In the 3rd lecture, I have taught you about the 8 different possibilities of images for different positions of the object in both concave mirror and convex mirror. So you need to clearly understand that 8 diagrams in order to work these 4 problems. Yeah, have you seen those lectures? Have you understood them? Can we go for these problems? Yeah, cheers and cheers Tango. Let us go for the first problem. A student wants to project an image of the candle on a screen. So a student wants to project an image. Only real images can be projected. So real and inverted images are the only images that can be projected. Real and inverted images are the only images that can be projected. Virtual images cannot be projected on a screen. Okay, let us recall the 8 diagrams. The convex mirror is producing only virtual images. So here we are going for a real image. So obviously here the mirror that is going to be used is a concave mirror. Okay, a student wants to project an image of a candle flame on a screen 60 centimeters. So here the student is having a screen. On the screen there will be obviously a image. The center of the mirror is called as pole. What is this particular distance called as? The distance between the pole and the distance between the image is simply called as V. What have they given V as? They have given V as 60 centimeters. How, sir? Look here. A student wants to project an image of a candle flame on a screen which is 60 centimeters in front of the mirror. So the screen is 60 centimeters in front of the mirror. Screen is 60 centimeters in front of the mirror. How is V measured? V is measured from the pole opposite to the direction of the incident light. V is measured from the pole opposite to the direction of the incident light. This is the direction of the incident light. So V is measured like this. From this point it is measured like this. So I am going to put a negative. All measurements that are measured opposite to the direction of the incident light is considered to be negative. Okay, sir. What next? Now you know what is V. V is here image distance. V is here image distance or screen distance. Both are same because the image is always formed on a screen. Okay. By keeping a flame at a distance of 15 centimeters. So they are having a flame. They are having a flame like this. They are having a flame like this, and this flame, yeah, this flame is present at a distance of 15 centimeters. So this particular distance, what is this distance? This distance is object distance. Object distance is given as U. U is also measured opposite to the direction of the incident light from the pole to the object. From the pole to the object. So here I am going to put minus 15 centimeters. This particular distance is going to be put as U is equal to minus 15 centimeters. Okay, sir. Now what is happening? In order to better understand what is happening, first let us check. Have they given the value of F focal length? No, sir. They have not given the value of F. Without the value of F, you will not be able to do the problem in a very neat manner. So first let us find the value of f. 1 by f is equal to 1 by v plus 1 by u. So what is this? This is simply the mirror formula. We have seen about this in the last lecture. So 1 by f, here 1 by v means I am going to substitute this minus 1 by 60. 1 by u means minus 1 by 15. Let us work the LCM. 60 is the LCM. In order to accommodate this LCM, I need to multiply 1 in the denominator and the numerator. So my answer is minus 1. In order to convert 15 to 60, I need to multiply 4 in the denominator and the numerator. After multiplying 4, I will get minus 4. So the answer is minus 5 divided by 60. So I will simply cancel this and I will have 1 by 12. So if I take the reciprocal of this, I will have minus 12 centimeters. Comfortable. So if this is 15 centimeters, the focus is somewhere around here. The focus, principal focus is somewhere around here. What is the distance of the principal focus? The distance of the principal focus is, this is the principal focus. F is equal to minus 12 centimeters. F is equal to minus 12 centimeters. Are you comfortable with what is happening? Okay, once I have found F, the distance between P and F is the same as the distance between pole and principal focus is the same as principal focus and your center of curvature. Principal focus and your center of curvature. Cheers. So that is basically what is happening over here. So this particular distance is 12, this particular distance is 12, the total distance is 48. So obviously this distance is 60. The screen is placed at 60, which is beyond my this thing, which is beyond C. Now what is happening, sir? Okay, let me draw the diagram. Now what is happening? Let me put the object slightly towards the back. Let me put the object slightly towards the back. Yeah. Okay. Just for neatness sake, nothing more. Yeah. Are you comfortable? U here is minus 15 centimeter. F here is minus 12 centimeter. Okay, sir. Okay, sir. Sir, in what color are you going to put the light rays? I am going to put the light rays using green color. This is my first parallel light ray. This parallel light ray is immediately passing through F. What next, sir? The next light ray is, I am going to put from C. Okay, and it is going like this. Sir, the light ray is going beyond the mirror. It's not really an issue. Always learn to extend the mirror. Always learn to extend the mirror. Now, what is happening? The light ray that is passing through C is nothing but the normal, and the light ray passing through the normal is reflected along the same path. It is reflected along the it is reflected along the same path. So both these light rays are coming like this, yeah, and they are meeting somewhere over here. Absolutely beautiful. They are meeting somewhere over here. Now what is happening? Where am I getting my image? Where am I getting my screen? I am getting my image right over here. I am getting my image right over here. So I am going to put something like this. This is my image. This is my image. So if I have my screen right over here, I will get an enlarged virtual image. I will get an enlarged real inverted image. Enlarged real and inverted image. Yeah, are you comfortable with how we did this problem? Let us check all the answers. Write the type of the mirror he should use. So obviously he should use a concave mirror, because a concave mirror only produces real images. Okay, that is the answer for the first question. He should use a concave mirror. What next? Let us go for the second question. Find the linear magnification of the image produced. Okay, let me find the linear magnification. Magnification, what is the formula? Hi by HO, which is simply written as minus V by U. Sir, you have not drawn arrow marks over here. I am absolutely sorry. If you are not drawing arrow marks in your light ray, then it is not even considered to be a light ray. Now let me go for magnification once more. Magnification is which is minus V by U. I am going to substitute my value of V over here. What is V? minus 60 divided by what is u, minus 15. Let me cancel these two negatives. Let me cancel 60 and 15. I will get 4. So magnification is minus 4. So this particular object is 4 times the height of this. This particular image is 4 times the height of this object. Let me repeat myself. This particular image is 4 times the height of this object. So I am getting a 4 over here. This is a real and an inverted image. So I am getting a negative over here. This is a real and an inverted image. So I am getting a negative over here. So here the linear magnification of the image produced is minus 4. What is the distance between the object and its image? This is a very, very beautiful question. Look here. Here I am having the object. Here I am having the image. What is the distance between them? Look, this entire distance is 60. This particular distance is 15. This entire distance is 60. This particular distance is 15. So 60 minus 15. This distance is simply 45 centimeters. This distance is simply 45 centimeters. So I know the distance between the object and its image. Draw a ray diagram to show the image formation in this case. Absolutely, this is the ray diagram to show the image formation in this particular case. Are you able to understand how I did the first problem? The model of this first problem is very, very important with respect to CBSE board exams. Yeah, cheers. Can we go for the second exam? Sorry, can we go for the second question? Can I rub this off? Can I rub this off? Okay, let me count from 5 and rub this off. 1, 2, 3, 4, 5. Yeah, I hope you guys have noted this down. I am going to go for the second problem. Let me read the second problem. Rohit wants to have an erect image of an object. Okay, so he wants to have an erect image. If you want to have an erect image, automatically it is a virtual image. That is fine. Rohit wants to have an erect image of an object using converging mirror. What is a converging mirror? Concave mirror is a converging mirror because all light rays parallel to the principal axis converge at the focus of the concave mirror. Sir, what about convex mirror? Convex mirror is a diverging mirror. Convex mirror is a diverging mirror. So he is asking us to use a converging mirror. So I am going to use a concave mirror, which is my converging mirror. I am going to use a concave mirror, which is my converging mirror. Okay, sir, why did you change the position of the mirror from this point to this point? Because they have asked for a erect image. Erect means it is a virtual image. Virtual image is found only behind the what mirror? Virtual image is found only behind the concave mirror. In order to accommodate that, I changed my diagram position from this point to this point. Okay, they have given the focal length. So Rohit wants to have an erect image of an object using converging mirror of focal length 40 centimeters. So here F, this particular distance is focal length. Let me mark them using this particular point is pole. This distance is same as this distance, center of curvature. Okay, so this distance from focus to pole, you are having your F. What is F? Minus 40 centimeters. Why are you having minus 40? Because the focal length is measured opposite to the direction of the incident light. Automatically the value is taken as negative. What else? Whenever you are noting down values, always use the sign conventions. Without sign conventions, your entire problem will simply collapse. What next? Specify the range of the distance where the object can be placed in front of the mirror for a erect image. Okay, so recall everything. Where do I need to place the object in order to get a virtual image? I need to place the object between principal focus and pole. Between principal focus and pole. Sir, what will happen between principal focus and pole? Between principal focus and pole. Sir, what color are you going to use the light rays? Once more, let us use green. So the light ray will be parallel. It will be reflected like this. A parallel light ray to the principal axis will always pass through F. What next, sir? I am going to put the next light ray over to the pole. If I am going to put a light ray like this, this is going to be theta I, angle of incidence. So this is going to be theta R, angle of reflection. These two light rays are diverging. If two light rays are diverging, they must be meeting at some point. That needs to be found out by extending the light rays in the direction behind the mirror. So they are meeting at this particular point. So what am I getting? I am getting an erect image. So an erect image means it is automatically virtual. It is automatically virtual. I am getting an enlarged erect virtual image. Enlarged erect virtual image. So in between P principal focus and pole, I will get an enlarged erect image using a concave mirror. So let us look at the first question. Specify the range. So the range is, for the first question, what is the range? The range is, they have given this particular measurement is 40 centimeters, which means 0 to 40 centimeters is the range. What next? Will the image be bigger or smaller? Obviously it is enlarged, so the image will be bigger. Okay, what about the third one? Draw a ray diagram to show the image formation in this case. Obviously this is the ray diagram. Sir, recall all the images, all the different types of images and positions with respect to a concave mirror using this problem has a focus point. Absolutely, Tangam. If your object is in between F and P, you are getting a enlarged erect virtual image. If it is right over here at F, both these light rays will become parallel, they will meet at infinity, then you will get a real inverted and a very enlarged image because it is meeting at infinity. What about between C and F? We saw the condition where object is present between C and F just in the previous problem. You will get an enlarged image beyond C. What about at a point on C? If the object is present here, the image will be present right in the bottom. If the object is present at C, the image will be present right at the bottom. The image will be real, inverted and same sized. C is very special. The image will be real, inverted and same size. Okay, sir, if the object is present at C, then what will be the magnification? Both are same sized. So HI by HO. But here the object is present above the principal axis. When forming here, the image will be present below the principal axis. So measuring this will be positive, measuring this will be negative. So automatically I will add a negative here. I will cancel both of them because both of them are of the same size. So magnification will simply be -1. So this is a very important point. Note it down. If magnification is -1 in a concave mirror, then absolutely, if the magnification is -1 in a concave mirror, then the object and the image are absolutely present at center of curvature. Okay sir, okay sir. What about beyond C? If you are going to have an object which is beyond C, then automatically the image will be formed. If you are going to have this thing beyond C, then automatically the image will be formed between C and F, and it will be obviously diminished, it will be smaller. Okay, what about at infinity? At infinity means this is a converging mirror, all the light rays will be focused at F, you will get a point real inverted image at F, point real inverted image at F. Yeah, okay sir. Now let us go for the third question. Absolutely, Tangam. Yeah, can I rub this off? Have you guys noted this down? Let me read the third question. An object is placed at a distance of 20 centimeters from a convex mirror. Okay, they have openly given this time that the problem has to deal with a convex mirror. A convex mirror is a diverging mirror. For the third question, the convex mirror is an absolutely diverging mirror. So this is the pole of the mirror. What next? So the center of the sphere somewhere around here can be called as center of curvature. In between pole and center of curvature, I have my principal focus. What next? An object is placed at a distance of 20 centimeters from a convex mirror. So I am placing an object at a distance of 20 centimeters. So this is my object. So this particular distance, it is measured from the pole opposite to the direction of the incident light, which is 20 centimeters. So U is equal to -20 centimeters. Here U is equal to -20 centimeters. What next, sir? from the convex mirror of focal length 15 centimeters. So they have given focal length separately. What is my focal length? The distance between the pole and the focus is called as focal length. Here f is equal to 15 centimeters. This is going to be a positive 15 centimeters. Sir, why are you putting positive 15 over here? Because here the focal length is measured along the direction of the incident light. Along the direction of the incident light. This is the direction of the incident light. The focal length is measured from the pole to the principal focus, which is also in the same direction. So automatically here focal length can be taken as positive. Okay sir, what next? Find the position, nature and size of the image if the object height is 5 centimeters. That is absolutely fine. They have given u and f. Let us try this particular problem. Okay, here let me draw this, do this problem. 1 by f is equal to 1 by v plus 1 by u. This is the mirror formula. Let me substitute all the knowns. 1 by 15 is equal to, okay, I do not know 1 by v. I do not know the image distance. I do not know where image is being formed. U is nothing but the object distance. Okay sir, what next? Here I am going to have minus 20. So let me put minus 1 by 20 over here because u is in the denominator. What next? Let me solve this. I am bringing this value over here. 1 by 15 plus 1 by 20 is equal to 1 by v. Because when coming here, this negative will become positive. Let me take the LCM. Here it is 60. So 15. What must be multiplied with 15 in order to get 60? Yeah, I think I need to multiply 4. So 4 plus. What must be multiplied with 20? What must be multiplied with 20 in order to get 60? I need to multiply 3. That is fine. Which is equal to 1 by v. So 7 divided by 60 is equal to 1 by v. What is the value of v? V is nothing but 60 by 7. V is nothing but 60 by 7. Okay sir. What is 60 by 7? Let me divide it up. I think it is 8.571. Let me think. Give me 1 second. 8.571 centimeters. That is fine. Here v is positive, which means it is a virtual image. Here v is measured like this. So here it is 15 centimeters. So v is formed between P and F. Let me illustrate with a diagram in order to better understand what is happening. A light ray is coming like this parallel to the principal axis. Okay, sir, that is when what will happen? It will be diverged in such a way that the light ray is coming out of the principal focus. What next, sir? I am drawing a light ray to C. Okay, sir. So this light ray is going to C. Now, because the light ray is passing through C, it is passing through the normal. A light ray through the normal will be reflected in the same path. A light ray through the normal will be reflected along the same path. It is reflected once more like this. Both these light rays, this light ray and this light ray are diverging. This is coming parallel, getting diverged like this. This is going along the path of the normal, getting reflected along the same path. It is going along the path of the normal, getting reflected along the same path. Both these light rays are diverging. Diverging light rays need to come from some point behind the mirror. So behind the mirror they are meeting right over here when extended. So here I am getting a diminished image, but it is a virtual image. I am getting a diminished virtual. What next, sir? Diminished virtual and erect image. Diminished virtual and erect image. Yeah, this is the simple idea of the diagram. How to draw the diagram? This is a very easy thing. Okay. Sir, kindly show us another ray with respect to this diagram. Absolutely, with respect to the pole. Angle of incidence is equal to angle of reflection. Angle of incidence is equal. So this is theta I, this is theta R. So if I am going to extend it like this, it will also meet in the same point. But you need not draw the last thing that I drew. I drew it just for illustration purposes. You need not draw this particular line. Sir, then why did you draw? It is always good to have a depth of knowledge of what is happening. Yes, I understand that marks are very important, but Tangam, without knowing what is happening, marks, I don't really think that is how you should study the subject. Yeah. Anyway, this is the diagram. What next? Let us check what they are asking for. They are asking for find the position. So the first question is they are asking for the position. So what is the position of the image? Position of the image is behind the convex mirror. Behind the convex mirror. Okay. Where V is equal to plus 8.571 centimeters. That's basically the position. What next? Nature. So it is diminished, erect and virtual. What next? The size of the image. If the height, object height is 5 centimeters. Okay. So they are asking for also the size of the image. So magnification is equal to HI by HO, which can be written as minus V by U, minus V divided by U. Let us use this formula. Minus of what is the V value? V value is 60 by 7. Let me use 60 by 7 whole divided by what is U value? Okay, U value is minus 20, which is equal to what is my this thing? This is minus V by U. What is He by Ho? I have used this over here. I want to use this. What is HI? HI is height of the image. I need to find out HI. Okay, what is HO? HO is height of the object. Height of the object is given as 5 centimeters. Let me put 5 over here. I will cancel this and this. What next, sir? Here I am going to cancel this particular value with this particular value. Both are in numerator. This is also in the numerator. This is also in the numerator. I can cancel like this. So this will become 3. This will become 3. What next, sir? Okay, the next thing is, let me multiply 5 and 3. Am I getting this right? This 5 will go over here. It will become to the numerator. Sir, this particular part is very confusing. I want a better illustration. No problem. Let me do a better illustration over here. 60 divided by 7 whole divided by 20 divided by 1. Which is equal to, so here there is a negative, here there is a negative, both the negative get cancelled. HI by 5, HI by 5. Let me rub this off so I can show you a better illustration of what is happening with respect to this problem. I can show you a better illustration of what is happening with respect to this problem. So this will come up. What will happen? When coming up, this fraction will change, the numerator and denominator will change. So 60 by 7 into 1 divided by 20, which is equal to HI by 5. Yeah. So I can now cancel this and this. I will get 3 over here. What next? Let me do the next step over here. Here 3 by 7 is equal to HI by 5. Let me multiply this. HI is equal to 15 by 7. Let me divide this. I think it will be 2.1. Yeah, am I getting this right? 2.14 centimeters. 2.14 centimeters. This is the value of HI. Yes, this is a diminished image. Why? The original size is 5 centimeters. This is 5 centimeters. But here I am getting only 2.14 centimeters. 2.14 centimeters. So the height of my image has been diminished. Are you comfortable with how I did this problem? Yeah. Okay. If you want to even get a better understanding of what is happening, you can try to find the magnification alone for this problem. How are you supposed to find the magnification alone for this problem? Let me do magnification alone. Magnification is equal to, okay, this is what I am going to do. Magnification is equal to nothing but this thing, minus V by U. What is the value of V? V is, let me check V, 60 by 7. V is 60 by 7. What about U? U is nothing but minus 20. So you will cancel this and this. What next? Here you will bring this up. If you bring this up automatically, what will you get? You will cancel. If you bring 20 by 1 up, you will cancel it like this and you will get 3 by 7. The value of 3 by 7 is lesser than 1. Here the denominator is greater. So the value of 3 by 7 is automatically lesser than 1. Because it is lesser than 1, the magnification, because it is lesser than 1, I am getting a diminished image. Are you able to understand in depth what is happening with respect to the third problem? So I have also found the size of the image if the object height is 5 centimeters. That is fine. That is fine. So that's basically the end of the third problem. Are you comfortable with how I did the third problem? Yeah? Cheers. Have you copied it down? Can I go for the fourth problem? Okay, Tango, I am going for the fourth problem. Let us look at the fourth problem. With respect to the fourth problem, what are they asking? The linear magnification produced by a spherical mirror is +3. So they are giving you that the linear magnification produced by a mirror is +3. Analyze this value and state the type of mirror that must be used. Analyze this value and state the type of the mirror that must be used. Okay. And the position of the object with respect to the pole of the mirror. Draw the ray diagram to show the image formation in this case. Okay, this is going to be an absolutely easy thing. How, sir? First, they are giving that magnification is +3. Here magnification is +3. If it is plus, automatically magnification is positive only for virtual and erect images. Virtual and erect images. Okay. Magnification is negative only for real and inverted images. Real and inverted images. So there are two possibilities for an image to be virtual and erect. What are the two possibilities? Let us consider a concave mirror and let us consider a convex mirror. First, let us consider a concave mirror. Here, let us consider a convex mirror. Here, what is going to happen? I will get a virtual image, but it will automatically be diminished. If the object is large, the image will be diminished in a convex mirror. What about a concave mirror, sir? In a concave mirror, the object will be smaller and the image size will be higher. The image size will be higher. Especially if the object is in between the pole and the focus, especially if the object is in between the pole and the focus of the concave mirror. Okay, here magnification is given as 3. If magnification is greater than 1, then the image size, if the magnification is greater than 1, then the image size is automatically greater than the object size because it is magnified. If the magnification is equal to 1, same sized image. If the magnification is greater than 1, image is larger than the object size. If the magnification is lesser than 1, image has been diminished. Image is being of lesser size than that of the object. Okay, sir. Okay, sir. I am comfortable with that idea. We have already seen this idea in the earlier lectures. So, if magnification is greater than 1, image size is automatically greater than the object size. This is the condition where the image size is greater than the object size. So, this particular problem will happen for a concave mirror if the object is placed between principal focus and pole. Okay, now let us draw this. The magnification produced by a spherical mirror is +3. Analyze this value. I have analyzed this value because it is positive. It is going to only produce a virtual image. If it is negative, it would have produced a real image. So because it is positive, my image is virtual. So there are two possible value options where I will get a virtual image. One is in convex mirror. In convex mirror, I need to place the image just in front of the mirror. I need to place the object just in front of the mirror. I need to place the object just in front of the mirror. What about here, sir? In a concave mirror, I need to place the object in between the principal focus and pole. Let me draw a better illustration of this, what is happening over here. So this is going to be my pole. So the center of the sphere, I can simply call it center of curvature. In between the center of curvature and pole, I have my principal focus. Respecting this particular condition, I am going to have an object over here. Okay, so obviously a light ray. If I am going to draw the object slightly nearer to the pole, I will get a better diagram. Always, if I draw it slightly near to the pole, I will get a better diagram. So, a light ray is going parallel to the principal axis and it is passing through principal focus. The next light ray is going and hitting pole. Angle of incidence is equal to angle of reflection is equal to angle of reflection. Okay, both these rays are diverging. diverging rays must be coming from some point. If I am going to extend this particular point, these two lines are meeting behind the mirror and forming a enlarged what else? Erect. If it is erect, automatically it is a virtual image which cannot be formed on a screen. This is basically what is happening here. So analyze this value and state the type of mirror used. So what is the type of mirror used? I am using a concave mirror. That is fine. I am using a concave mirror. What else, sir? The position of the object with respect to the pole of the mirror. With respect to the pole of the mirror, the object which is usually the object distance which is usually denoted by u. Here because the u is measured opposite to the direction of the incident light, I can simply say this is minus u. This is also my object. The object is placed right in front of the mirror in between F and P. So object is between F, principal focus, and P, pole of the mirror. Draw the ray diagram to show the image formation. So this is basically the ray diagram to show the image formation. Yeah, hope you guys understood this particular problem, fourth problem. Okay sir. What next, sir? We will work more problems in next lecture, and also we will work more 1 mark MCQs, logical based questions, analytical based questions, and also numericals in this particular series of lectures based on light, reflection and refraction. So let me tell you guys, the one thing I want you to do is immediately subscribe to us, click the bell icon, recommend our channel to your friends and relatives on the social media. Why, sir? Because we are going to have so much fun learning physics, chemistry, biology, economics, political science, history, maths over here at Gully Classroom. Do not miss out on this. Cheers and thank you. See you guys in the next lecture. Yeah.